And welcome to the Daily Space Weather Show. We had a coronal mass ejection impact somewhat unexpectedly yesterday, a coronal hole high-speed stream looking weak, and more space weather on the way to arrive on the 14th. We'll tell you all about it and more here at the Smash News Network, least busted name in news. This is the past 24 hours from SDO, and ionized helium 304 angstroms is the wavelength. And let's take some closer looks here as we have an expiring Earth-facing quiet, especially up there in the northwestern limb. Here's a close-up of the northern hemisphere. And yeah, this northwestern limb right up here, this sunspot, poses the kind of risk for large solar flares that we would expect with the magnetic fields that it harbors. So it is a beta gamma delta class sunspot, and as it approaches the limb, the likelihood of producing large flares, including X-class events, is extremely high and indeed rising. So we have had a minor decline in solar activity over the past 24 hours, but doesn't change the fact that there is space weather on the way. We're expecting a CME, coronal mass ejection impact, sometime late in the day on the 14th, maybe early in the day on the 15th of September. Here's the equatorial view. Again, very high likelihood of large solar flares, especially in the northwestern limb. There's also a filament up here, which we've actually named the Selena Gomez filament based on one of our viewers' recommendations on Twitter. Why did I pick that one? Because it looked like, well, it's the filament in close proximity to that large sunspot, so therefore it has a high likelihood of ejecting. Let's move to the southern hemisphere. You can see huge plasma filaments over there on the northeastern limb as well. Down here in the southern hemisphere, there's another huge plasma filament down here. This one's called the Eugene Bagashov filament, and it is gigantic. It's becoming a prominence as Mr. Bagashov becomes a prominent scientist. Anyway, we'll zoom back out here after that plays through. There's one more 24-hour video from SDO 304 angstroms wavelength. And before we continue on, do yourself a favor and press that like button. If you haven't already done so, please do. You've found yourself viewing the most comprehensive daily space weather content in the known universe. Also the most detailed imagery of the sun you'll find any place right there on our channel. So thanks to all of our new viewers, new subscribers, etc. Again, don't forget to press that like button, leave a comment, press share, etc. Thanks to everybody who has. Congratulations on realizing that the channel exists. Before we continue on, a couple more brief things. If you want to support the channel via subscription services, become a member of the Smash Team, the official subscription services site of the Smash News Network, least busted name in news. Smashomash.com/Smash Team. The best value is the gold annual paid-up subscription. There is also a silver and a bronze level for additional content. Smashomash.com/Smash Team launched officially in October of 2021. Moving right along here to view the latest SDO intensitygram. That is yesterday plus today from SDO. And besides one sunspot evaporating down here in the southern hemisphere, not a lot of changes happening there. No major growth, no major depreciation of sunspots, no new groups rising in the past 24 hours. Here's yesterday plus today from SDO in the colorized magnetogram. And we'll be keeping an eye on that northwestern limb. And when I say eye on, well, the pun is intentional. Let's see what's been erupting as far as volcanoes. There's at least one eruption back on the list here. Make it two. Ulawun exploding there on the Isle of New Britain, Papua New Guinea, producing a 9,000-foot plume of volcanic ash. It's a flight level 090, flight level 070 over to Kono as it also explodes. And there's Yasur producing dense ash emissions as seen in this photo here. Dense ash emissions there from Yasur on the Isle of Tanna, part of Vanuatu, launching lava bombs and venting steam and gas, so a phreatic explosion there at Yasur. Kilauea continues to effusively erupt there, and some lava fountaining there, and some building of cones, actually, at Kilauea in the lava lake. Halema Uma'u is where the action is at Kilauea. Popocatépetl exploding in central Mexico, flight level 230. Fuego exploding in Guatemala, flight level 190. Revenador exploding in Ecuador, flight level 140. And Sabancaya exploding in Peru. It's a 23,000-foot ash plume. Please don't pole vault the caldera. By the way, today's featured product is Google. Yeah. If you're using it as a verb, well, first of all, Google doesn't really want you to use Google as a verb. And if you are using it as a verb, it's making my ears bleed. If you are using it as a verb, please use it correctly. It means to obtain biased information using the Google search engine to research something on the internet. Yeah. The web search, the Google web search, yes, providing biased information on the World Wide Web. Did you know that Google is involved in the world's largest antitrust case since Microsoft about 25 years ago? Yeah. It's the government's claiming anti-competitive practices. Let us know what you think in the comments. We've been talking about this for quite a while on the channel because, well, I stopped using Google back in 2012 as search because I noticed the biased search results. So I stopped using it because I prefer objective search results. That's why I do not use it as a search engine, although I do use it on YouTube because, did you know that YouTube is the world's second largest search engine? Yeah, it's also powered by Google. So, what do you think? Do you think it's a monopoly? Let us know in the comments. Today's featured product on the Amazon shop is cocoa. Yeah, so that bag right there is $31. It might seem like it's expensive until you realize it's a 5-pound bag of organic. If you're buying those little tubs in the grocery store, you are getting ripped off. Buy it through our Amazon shop instead. Did you know that cocoa can increase your nitric oxide levels? Yeah, nitric oxide. There are people that take very expensive supplements because of muscles. And nitric oxide. It's important for muscular performance. It increases your effective blood oxygen levels. So it's a performance-enhancing substance that is legal in endurance sports. Cocoa, basic cocoa powder. I drink some in my coffee on many mornings. And $31 there for 5 pounds of organic through our Amazon shop, amazon.com/shop/smashomash. Yes, check it out. Today's featured product on the Hemp Lucid shop is the Focus Mushroom Gummies. If you haven't seen those, check them out. The main ingredient here is lion's mane mushrooms, and it's not going to make you jittery. At least it doesn't make me jittery, so try them out. If you're looking for focus, perhaps the Focus Mushroom Gummies. No, they're not magic mushroom gummies. They're Focus Mushroom Gummies. So that's the featured product on the Hemp Lucid shop. Links below the video to all of that, as well as on our homepage at smashomash.com. Moving right along to our earthquakes. What's been going on Earth as far as quakes? Well, there's the past 90 days. And let's take a look at the past 24 hours. Largest quake in the past 24 hours was at 6.3 at the Philippines. That was at 11:03 Universal Time yesterday morning. 6.3 there, striking the Philippines at 11:03 Universal Time. We'll call out quakes of a 5 or greater magnitude like this 5.0 in the Aleutians. That was at 23:17 Universal Time yesterday evening. So things pretty calm here over the past 24 hours. Also a 5.1 hit Indonesia. That was at excessive depth there, nearly 650 kilometers depth of that 5.1, which occurred at 5:34 this morning Universal Time, and that is the end of our list. So taking another 24-hour look at the sun here. Here is SDO, 171 angstroms, the house favorite wavelength. Now it does appear that there is a new active region rising down here in the southeast, as I see huge magnetic looping going on down there. Not as huge as the setting region up here. And again, we'll keep an eye on this northwestern limb because it is currently the most likely place to see a large solar flare. So not only seeing plasma instability there, but also seeing the kind of magnetic fields that you would expect, known as beta gamma delta class type sunspot. The 10.7 centimeter radial flux now down to 154 solar flux units. So no major changes in sunspots, but quite a significant decrease there in the radial flux over the past 24 hours. There is the black line, that is the radial flux. That is the 1 year graph of the F107, as it's known. The red line there is the sunspot number. Next, how about the Space Weather Enthusiast dashboard? Again, we did see an unexpected coronal hole high-speed stream show up, and also we saw a coronal mass ejection strike yesterday. So that was perhaps a bit unexpected. Certainly was a bit unexpected. We'll get to that in a moment. There's the Space Weather Enthusiast dashboard here. Just forecasting a little bit of geomagnetic unrest late tonight, early tomorrow, and on the 15th as well. So maybe that's a CME impact. It looks like it is a CME impact. They're expecting it a little bit later than I was. I was expecting it sometime late in the day on the 14th at the earliest, or perhaps early in the day on the 15th. So space weather coming in despite a small decrease in solar activity. Let's take a look at Earth's magnetic moment from space. That is the past 4 hours of magnetohydrodynamic pressure. We show it daily on the channel. Hopefully you're not spooked and frightened of this. That is the solar wind striking Earth's magnetosphere. The plasma pressure, the magnetohydrodynamic pressure, to about 12 Earth diameters. Here are the past 4 hours of Earth's magnetic moment from the ground, and we've seen some significant aurorae. If you've got auroral imagery to share, hit us up on Discord. There are all kinds of ways to contact us. You could also tag us on Twitter or on Instagram. If you've got auroral imagery, we'll consider featuring it on the channel. You can find all kinds of links with all kinds of ways to reach us, including email address at smashomash.com, right on the home page. That's the past 4 hours of Earth's magnetic moment from the ground. Ground magnetic perturbations depicting magnetic flux density. Next, a general global average of geomagnetism, and we got all the way up to KP 5.67 yesterday with a CME briefly brushing past. So it wasn't a major impact. We are seeing a coronal hole high-speed stream now, and it's looking pretty weak. So there's that CME impact, and then here's the coronal hole high-speed stream showing up, and it's pretty weak. And you can expect an uptick in coronal holes in the coming 2 years. Next, the real-time solar wind. We are seeing a shift in the phi angle here, as well as the magnetic fields. So here's the coronal hole high-speed stream impact. You can see it made it up to about 15 protons per cubic centimeter, and then it dropped off as the solar wind speed came up, but not very high, only to about 430 kilometers per second. Maybe 440, so a pretty weak coronal hole high-speed stream there. But this is the real story here. Solar wind density made it up over 70 protons per cubic centimeter yesterday. So that was a CME impact, coronal mass ejection. And it was followed by some very strong magnetic fields also. The total field got up to 20 nanotesla with a negative BZ of negative 19. So a very strong negative BZ component there. That's the vertical component of the magnetic field measured at Lagrange 1. At that time, it was measured by the Discover spacecraft. And that was enough to drive this KP 5.67. So a mild geomagnetic storm activity there. And that slowly subsided throughout the day. The BZ component got weaker and the field got weaker as well. And then that weak coronal hole high-speed stream showed up. So things not too exciting there at the moment. Current conditions are about 414 kilometers a second for the solar wind speed. Solar wind density here not even 5 protons per cubic centimeter, so quite nominal there. It's barely a blip on the radar. GOES magnetometer showing a little bit of spiking here, as you may come to expect from CME impacts. Quite a bit stronger field there. If we show the 7-day, you can see a significant magnetic spike there showing up on the GOES 16, making it all the way up to nearly 190 nanotesla there on the GOES 16. So normally we just show the 3-day. There's that. And next, our line of sight field plot. Our top view ecliptic plane field plot, rather. So there is a North Pole current sheet trying to break through here. It looks like it's popping back through again. So we may see a North Pole current sheet show up as early as tomorrow. And again, there may be an active region or a sunspot rising in the southeast. So that is the kind of thing that you would expect. That's the sort of thing that would constrain the polarity there, that plasma in the heliospheric current sheet as depicted here. Here's the last image. See, there's a North Pole current sheet right there. And there is the sector boundary crossing. So sector boundary crossing, assuming all things remain the same, likely to show up before tomorrow's daily space weather show. Earth is about to move into a North Pole current sheet as additional space weather is expected to arrive. Next, here's our line of sight field plot. And here the blue field is what you'd call the toroidal field, which gets all jumbled up looking around solar maximum. It's much more orderly around solar minimum. The poloidal fields here are depicted in red and blue. Red and green. Red is the south and green is the north poloidal fields. And we're going to revisit the poloidal and toroidal fields here in a moment. Again, at solar maximum, as you can see there, the blue lines represent the B field. That's the field going through the magnet, this magnet being the sun. You can see they're very jumbled up. That is what you see around solar maximum. Around solar minimum, they're very orderly around the equatorial zone. So, again, we're going to revisit that here in our brief cosmology section. But before we do that, let's move to coronal holes. So here's the latest imagery there, the last 4 days of coronal holes. And we've got South Pole and North Pole oriented coronal holes on the Earth-facing portion of the solar disk here. So if you bring up the last image, there you go. So we've got South Pole coronal holes stretching from the northeast to the southwest. And then we've got North Pole oriented coronal holes in the northwest and the southeast. Here's the view from SDO for the past 24 hours. Once again, these are South Pole coronal holes. These are North Pole coronal holes. Again, there is a sector boundary crossing that will probably arrive before tomorrow's daily space weather video. And let's zoom in a little bit closer there. We can expect a high-speed stream from this coronal hole as well, or associated with that coronal hole, in about 3 days. So plenty of space weather on the way here, including the coronal mass ejection that we talked about yesterday. So coronal mass ejection likely to arrive late in the day on the 14th of September or early on the day 15th. And then, of course, additional coronal hole oriented high-speed winds showing up. And let's move to sunspots. So what's the deal with sunspots, you ask? All right. A very high likelihood of solar flares, especially up there in the northwestern limb. I think I've said it a few times. I don't mind saying it again. It's sunspot 3423. That is the big solar flare player there. And also an honorable mention goes to 3425. Also a beta gamma delta class sunspot with significant umbre. It's large, it's magnetically complex. We've got multiple magnetically complex sunspot groups on the Earth-facing portion of the solar disk. What can I say? Let's take a look at sunspots from SDO. So here is another 24-hour video. That's the SDO continuum along with 131 angstroms to highlight the active regions. Pretty sweet composite there, right? And here is just the continuum by itself. Again, not a lot of changes happening there besides the degradation of one sunspot in the southern hemisphere. The rest of those are rather stable for the 24 hours depicted in that video. We're also going to show some additional wavelengths today. Here's 1600 angstroms. That's ionized carbon. You might see some brightening there as nuclear fusion occurs before your very eyes, and carbon is created right there on the surface of the sun in plain sight, right out in the open. As the star jumps up and down and says, "Look what I can do. I can make heavy elements right there in my lower atmosphere." And we'll also show 1700 angstroms. This is more similar to the continuum. It shows active regions as sunspots and plages. Sunspots and plages. Again, plenty of active regions here on the Earth-facing portion of the solar disk. It has been an exciting few days for space weather. And let's talk solar energetic particles and solar flares. As far as SEPs go, nothing significant there. The ghost proton flux largely flatlined for an extended period. Don't expect that to continue. Again, because solar energetic particles are associated with large solar flares. Speaking of solar flares, there's the GOES X-ray flux, and it has dipped a little bit here. So a little bit of a dip in solar activity, generally speaking. There were 2 M-class events yesterday, and so far they've been underperforming today. But the likelihood of large flares is indeed there. So let's take a look at, here's SDO 131 angstroms by itself. Another 24-hour video there from Solar Dynamics Observatory. And let's don't forget 94 angstroms. Yowzers! That is pretty sweet. And let's take a moment to look up. There is our star chart from skyandtelescope.org. That's what's going on over Lehigh Valley, Pennsylvania, which is where we're located. If you're a new viewer, let us know where you're located. Or if you've just never told us where you're located, hit us up in the comments. If you're up before dawn, you might see Mercury there rising ahead of the closest star. If you've got low light pollution and clear skies and a low horizon, you might see Mercury and a great sliver of a moon there, as we're like a day or two away from new moon. Also the 3rd brightest object there visible in the morning sky, and the sometime 4th brightest object visible there in the morning sky, Jupiter. Also the brightest intrinsic object visible from our solar system, also up there in the northwestern sky there, the tail of the swan, Deneb. Let's continue to the astronomy photo of the day. What do you think of that? That's pretty crazy, right? Yeah, that is berserk. And what that is a cloud of hydrogen in a polar orbit around that galaxy. I know it looks very strangely. It's hydrogen. And in fact, we're not even sure if the hydrogen came from inside or outside of the galaxy. We're not sure if the galaxy is attracting the hydrogen or if the galaxy is emitting the hydrogen. That's the astronomy photo of the day. And remember how I talked about toroidal and poloidal fields? Well, let's go back to that. So, here is the sun. Yeah, the sun. There it is, around solar minimum. That imagery right there is from 4 years ago today. So that's the 9th through the 13th of September 2019. Just a couple of months there before solar minimum. And what you'll see here is this very orderly toroidal field. There it is. It's very orderly around solar minimum, and the poloidal fields are also very orderly. They're in these fixed locations at the poles. And what's important to understand about this is that other stars seem to have their rotations somehow proportional to their poloidal and toroidal fields. In other words, stars that have an extremely chaotic toroidal field have a tendency to have a faster rotation, and stars that have an extremely powerful poloidal fields have a slower rotation. Interestingly enough, when we see solar cycles that are weak, we tend to see longer solar cycles. So solar cycles that have extremely low numbers of sunspots, they have a tendency to be longer cycles. Is there some kind of a relationship between rotational speed of a star and the proportion between the toroidal and poloidal fields? Well, other stars seem to suggest that there is such a relationship. I mean, on the galactic scale, we also see, by the way, we see galaxies that have bright disks tend to have dim jets, and galaxies that have dim jets tend to have bright disks. But this is sort of a different feature here, as galaxies and stars are very different things. The toroidal versus poloidal magnetic fields in sun-like stars, a rotation threshold. So this is what I'm talking about. If you want to read that paper, it's from 2008. Toroidal versus poloidal magnetic fields in sun-like stars, a rotation threshold. And like I said, there is a tendency for stars that have strong activity around their equatorial regions to be faster rotating stars than ones that have strong jets at their poles. So these are just facts. Does this somehow relate to the sun? Well, perhaps it does. If you want to read the paper, again, it's called Toroidal versus Poloidal Magnetic Fields in Sun-like Stars, a Rotation Threshold. And that brings me to this imagery once again. It's important to understand this because for some reason the poloidal fields are overlooked when indeed they're actually creating the toroidal field. Those poloidal fields are like, I should say the toroidal field. The toroidal field there, shown in blue, the B field, that is effectively the net field of the overlap of those polar fields. Anyway, continuing on, let's take a look at the solar system. And before we do that, let's pause for station identification. This is the Smash News Network, least busted name in news. Here's your solar system forecast. This is where we've got things today. We'll advance this 1 week. We will have a crescent waxing moon on the 20th, and we'll be only 1 day from the equinox or so on the 20th of September as the September equinox approaches. Next thing we'll look at is coronal mass ejections, and we have had some yesterday. Are they earthly directed, you ask? I don't think so. However, we will take a closer look. That is 98 frames from yesterday at George Mason University. Okay. Here are an additional 31 frames from today. And there are some additional CMEs there. Let's take a look at what's going on by showing the C2 and the C3. All right, so here's this one. That was early in the day yesterday. The guy already determined that's not likely to be earthly directed. There is an interesting thing here. We see some relativistic particles striking the aperture there on the C3. A couple different occasions. Somebody asked on Twitter about that. That is relativistic particles there striking the aperture. So That is essentially like a solar energetic particle event. Keep in mind, these spacecraft are not inside a magnetosphere. They're struck directly by the particles. Unlike you down here on Earth, where there's all kinds of atmosphere in between you and the particles, as well as the Earth's magnetic fields. Anyway, let's continue on here. Here are some additional blown up coronagraphs. And I'm just going to say these are not earthly directed coronal mass ejections that you're seeing here. The likelihood of coronal mass ejections is actually very high, nearly 100% at the moment. Let's also take a look at stereo A here briefly, as it's going to start to show us a little bit more angularity there in its view. So there's the stereo A raw coronagraph on the left and the difference imagery on the right. One rather dense impulsive CME there popping off in the southeastern limb. Not likely to be earthly directed. Definitely not earthly directed. Well off to the south and east. And that brings us to filaments. Again, massive filaments. And the Selena Gomez filament here is looking like it's a little bit unstable. So that's our favorite kind, as those are the most likely ones to eject. Again, it is in close proximity to that very complex sunspot group. So that's what you want to see, right? Certainly. So there you go. There's the El Teide Spain ground-based hydrogen alpha scope. You can see the Eugene Bagashov filament there becoming a prominence down in the southwestern limb. And several other filaments could get named here. I mean, check it out. You've got 1, 2, 3, 4. At least 5 more filaments that could get names. And here is the... Oh, and by the way, if you want to name them, do it over on Twitter. Follow the hashtag #NameThatFilament. And you can name filaments after living people. Name them after your friends. Name them after your foes. Name them after yourself. And check it out. There's the Eugene Bagashov prominence showing up down there. Unfortunately, that one's becoming less and less likely to produce to become a CME that strikes Earth. So, you know, one of the great things about naming filaments after living people is if they do end up striking Earth, then it would become the Eugene Bagashov solar storm, the Eugene Bagashov geomagnetic storm. That's what you want. And it's almost time for our bonus features segment, so let's take a look at the last couple of hours here from the GO 16 SUVI. Whoosh, there you go. Filaments, 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 and large magnetically complex sunspots. Some crown prominence activity happening at both poles. Another feature you can expect to continue for the coming 2 years. In fact, for the next about year, you can expect it to increase. Anyway, here come bonus features. Satellite charging hazards, we do have some minor ones here. Surface charging hazards are caused by low-energy electrons which build on the outsides of spacecraft. Those are located in Mexico and the Eastern Pacific. At the moment, minor surface charging hazards there for satellites. The GOES electron flux here kind of low, as you may have expected if you come to watch our videos. If you are a regular viewer, you would have been expecting a low electron flux. And there it is, as forecast. Here's the 1-year graph to put it in context. That is the greater than 2 mega electron volt electron fluence from Solon.info. And here's the forecast model. It looks like NOAA's expecting it to be close to what we have or a little bit lower in the coming days. I would tend to agree with that forecast. What about you? Let us know in the comments. Now keep in mind that is measured using radiography from way up at the geosynchronous orbits of the GOES. And they're using radiography to measure that electron flux from like 23,500 miles of altitude. They're measuring it at the F layer of the ionosphere. And here's the vibrational frequency of the layer of the F layer of the ionosphere. And indeed, we're seeing quite a lot of low frequency anomalies now, as you would also have come to expect if you're a regular viewer of the channel. Isn't it great to see the data correlate in an expected fashion? Isn't that what you want to see, folks? Don't you want to see facts connect to other facts in a predictable way, giving insight into the actual physics behind stuff? Isn't that just splentacular? I thought so. Anyway, here's the anomalygram. We showed the raw vibrational frequency. Here's the anomalygram, and you'll see a bunch of low-frequency anomalies there spreading from the pole down toward the equator. That is a thing that is a normal thing when plasma shows up. Space plasma. It scintillates the ionosphere, and it causes it to effectively change altitude, and hence you get low-frequency anomalies around geomagnetic storm conditions. So there you'll see it shift from mostly high to mostly low-frequency anomalies. That is depicting anomaly in megahertz from a 30-day median. And here's the latest image. That's 10:30 universal time for the ionogram and 10:30 universal time for the anomalygram. Not a major impact by any means. We'll also show the total electron content forecast. It's free electrons to about 12,500 miles of altitude. And those free electrons cause signal refraction, which is what you're seeing a forecast of here. Your GPS satellite must communicate through the outer portion of the inner Van Allen belt, the outer plasmasphere, the inner Van Allen belt at times, the inner plasmasphere, and the ionosphere. The free electrons in all of those layers cause that signal refraction. And things are remaining fairly orderly here, despite a bit of a dip in the electron flux. So that's what's going on over a worldwide basis. Here's the electron content anomaly from the 10-day average over North America. We are seeing some high electron counts there around places like Cuba, also northern Canada. So the Caribbean there and northern Canada seeing some high electron content anomalies. We'll close out the space weather section of the video before we show some forecasts about hurricanes. There is the intensitygram, and here is the magnetogram. Again, that's the most likely sunspot for large flares. It remains beta gamma delta class. This group over here, also beta gamma delta class. Look at all those North Pole umbrae there. Quite spectacular. That group down there, beta gamma delta class. That group up there, only alpha class. So anyway, here's the full disk rock back. We don't want the video to be too long, so this group down here is also beta gamma delta class. And oh, this group here, I think I already said that's beta gamma delta class. So lots of sunspots here capable of producing large flares. And here comes the meteorology segment. So we're going to show you some forecasts here and some of the basis by which I forecasted this hurricane weakening. And indeed it will be weakening. However, it will be showing up at the Bay of Fundy in between Maine and Nova Scotia with at least close to hurricane force winds. It might drop just below a hurricane as it gets there. Keep in mind there is some cooler water there. We're showing sea surface temperature anomaly here in the color gradation, and the animation there is winds. So again, it is still significant hurricane. If we switch to regular sea surface temperature, there is a lot of warm water in between Nova Scotia and that Hurricane Lee. So nearly 80-degree water there. Fortunately, it does drop. There's actually some even warmer water up there. Fortunately, up here it does drop down to only 66 degrees. So that will help to weaken it. However, it's still going to carry a ridiculous amount of moisture. And in tomorrow's video, we will show you the rainfall forecast. We don't go beyond 3 days in our forecasts. So that is what's going on. It's got that hurricane has a fairly smooth course to drop massive amounts of rain on the area. Anyway, we'll briefly show the planetary winds. There are the surface winds of the eastern world. Here are the jet streams. Jet streams of the central world shown here. Surface winds shown here. Surface winds of the west. And there are the western world's jet streams. So here comes some forecasts. So we're going to advance. This is the European forecast. We're going to advance this 3 days into Saturday around noontime. So there is Saturday at 12 noon Eastern time, and that is about when the outer bands of that system are going to start striking both New England and Nova Scotia there, as it's going to crash right into the Bay of Fundy. So that's a Euro forecast. Here's the GFS forecast, putting it in a very similar location. And here's the icon forecast. We showed this one yesterday. That's going to have it farther to the east and a little bit to the south. So there's the icon. Again, there's the GFS. And there is the Euro model. As far as wind speeds on the GFS model, for example, around landfall, expecting winds to be, see, a little bit diminished there. So looks like sub-hurricane force winds there, as that cold water is going to make the system depreciate just before making landfall. Mark my words. Anyway, here's some satellite imagery for you. And let's zoom in a little bit closer there. There is Hurricane Lee. Not particularly organized, and some good news is that it's picking up some entrained dry massive air, which will be more evident on the water vapor map. You can see some dry air to the northwest of the system there. That's a good thing. That will also serve to weaken it. In fact, all of that dry massive air in between North Carolina and the hurricane will not be beneficial for the hurricane. That will create wind shear, and that will help to break apart the upper levels of the system, further reducing its ability to create convection. Period. Facts. Next, our weather.gov map, and check it out. Frost warnings continue here over the northern portions of Minnesota and Michigan. Also some flood watches there around the mid-Atlantic and New England states. We'll briefly scroll down and show you the key. There is the key. Weather.gov. Go to the National Weather Service homepage, weather.gov, if you've got weather warnings in your location. And here come some forecasts. So there's the GFS model for mean sea level pressure and winds for the next 72 hours. 72-hour GFS sea level pressure and wind forecast. And I don't know, that model's not really showing it weaken very much. I suspect in the coming days that's going to weaken. Again, there's a lot colder water just south of Nova Scotia there. So that might be a little bit, that third day there in the forecast might be a little bit erroneous. Here is your pressure and precipitation forecast over the same period, the 72-hour GFS model, which is indeed showing it break up a lot here. You can see it's becoming a lot less organized there. So a lot less rotational value. The wind speed should be dropping quite a bit in the coming days. Again, that's not going to stop it from dropping an insane amount of rain and creating a storm surge, because the winds will still be rather high. Last but not least, here's the jet stream forecast, and the jet stream will also help to weaken the system here in the coming days. That's the 250 millibar winds, again, otherwise known as the jet stream. TropicalTidbits.com. Last but not least, the temperature anomaly forecast in degrees Celsius. The same model, the GFS 72-hour model. And some rapid temperature swings there around the western Great Lakes states. Switching from high to low temperature anomaly there in short periods of time. Some big temperature swings happening out there. Next, our lightning mapper. This is the past about 10 hours of lightning. can see the outer bands there of Hurricane Lee producing some, also some heavy lightning in South Carolina. And indeed, we had some lightning in Pennsylvania late last night. And here's a real-time lightning map. Do we have any terrestrial strikes? Certainly some there around the eastern Pacific. And a little bit of lightning there around Hurricane Lee as well. Once again, if you enjoy the content, please visit our links, smashomash.com. We created a massive web ring starting back in 2019 to benefit people like you. We are free speech purists, by the way, not free speech phonies, like certain tech executives. We're free speech purists, so visit our links, visit us on social media, and help support the channel, as we have massive overhead and we make just this side of nothing to put out the videos. Anyway, we'll close out with U.S. Doppler radar, clouds and fog, and water vapor. So here is the full 50-state view, depicting vertical motion of the air column from ground-based Doppler radar systems. We'll focus on the lower 48 to close this thing out. So that's what's going on. Here is clouds and fog. And here is water vapor. And you can see that dry mass of air there pushing down toward Delaware. Again, that will help to create additional wind shear and push additional dry mass of air into the path of Hurricane Lee. Here's your recap. U.S. Doppler radar, clouds and fog. And there is water vapor. Anyway, thanks for tuning in. Congratulations on realizing the channel exists. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. Back to the bunker with me. And while I'm gone, may that solar wind be at your back.